Welcome to this continuation of our Service Foundry OBI series. In this session, we're going to apply OBI to a Go application, demonstrating how we can instrument tracing with zero code changes using eBPF. Additionally, we'll explore how to optionally correlate logs with traces using Trace ID and Span ID. This does require minimal changes to your application's logging format. You'll see how OBI's lightweight integration helps you trace Go applications in Kubernetes environments without needing to touch your business logic. Let's get started. For this demonstration, you can access both the source code and the pre-built Docker image easily. The source code is publicly available on GitHub under the otel-examples repository. Inside that repository, you'll find the otel-go-example directory, which contains all the code we're using in this demo. The Docker image has already been published to Docker Hub under my account. The image tag is createmall/otel-go, example colon 0.1.0. You can pull and use this image directly if you want to follow along or deploy the example into your Kubernetes environment. These resources are ready to use and open source, so feel free to fork, modify, or experiment with them as you explore OBI instrumentation in Go applications. This screen shows how easy it is to deploy an application using the Service Foundry Console. On the left side, you can see a form where users enter common information about their application. This includes the application name, namespace, Docker image repository and tag, the service port, and other basic settings. Based on these inputs, Service Foundry automatically generates Kubernetes manifests such as deployment, service, and ingress files. Below the form, users can add or remove resources using the Add Resource and Remove buttons. This makes it simple to manage Kubernetes manifests without manually editing YALM files. On the right side, we can see the ingress YAML file for this Go application. It defines how incoming traffic is routed to the service through Trafic, and the host is configured as otel-go-example.nsa2.com. The service listens on port 8080. Now, notice an important detail in the deployment YALM file. A label named Instrument is added with the value OBE. This label tells the OpenTelemetry eBPF instrumentation, or OBI, to automatically instrument this pod when it runs in Kubernetes. By simply adding this label, OBI can capture traces without modifying the Go application source code. This approach enables true zero-code tracing, making observability setup fast, consistent, and effortless through Service Foundry. Now that the ingress is configured, we can access the Go application through a public URL. In this example, I'm sending a request to the endpoint otel-go-example.nsa2.com/sleep ? Duration equals 3 seconds. The response shows a JSON message. Message: slept for 3 seconds. By hitting this endpoint, we simulate a request that takes 3 seconds to complete. This helps us generate trace data so we can verify that OpenTelemetry eBPF instrumentation is working properly behind the scenes. This is a simple but effective way to trigger real traces for our demo Go application. Now we are on the Grafana Explore screen, viewing the Jaeger data source. In the search form, we've selected the service name otel-go-example and the operation name get/sleep. Below, we can see a list of traces captured by the OpenTelemetry backend. These traces were generated when we made requests to the /sleep endpoint in our Go application. This means the otel-go-example pod is now fully instrumented with traces, thanks to OBI. Each row in the trace table shows a unique trace ID, the name of the operation, the start time, and the duration. If we click on any of these trace IDs, Grafana will show us all the spans and timing details of that request, helping us understand how long each part of the request took and where time was spent. This confirms that observability is successfully enabled and the traces are being collected in real time.